Yeah, good evening, Manas.
Hi, sir. Good evening.
Yeah, okay. So previous week, whatever we have done, you tried it and checked it. It's working.
Actually, last week I focused on this AWS because I'm planning to complete by Jan month end that exam. So,
Practical exam, huh?
yeah, no, AWS certification, cloud practitioner.
Okay, okay, good. Fine. Let us start by 7:30. Let us see if
Okay.
it's done. Okay. Okay. Previous week we discussed about started with Kubernetes, correct? So once we did the complete the practical, we started with Kubernetes. What is Kubernetes? Do you remember?
K8s,
Hmm? K8.
Kubernetes.
Okay.
Yes.
Okay. What is this actually? What tool it is? What tool it is?
Deployment kind of tool.
Hmm?
Deployment.
Deployment tool. No, it's an artist.
Container container orchestration tool.
Yes, container orchestration tool. I told you, it's nothing but the captain of a ship. I told you the example, right?
Yes, right.
It's a Greek word for helmsman or captain of a ship. Then Kubernetes is the symbol says that it is like a wheel of a, I mean steering of a ship. We also call it as K8s, as there are eight characters between K and S. And container management, it's an orchestration tool developed by Google Lab actually and donated to Cloud Native Cloud Front Cloud Native Cloud Foundation. Then it's an open source written on Go language, also called as K8s. I told you that it's a tool or engine that automates deploying, scaling, managing all the container applications on a group of servers. So mainly the best examples would be to Kubernetes, Docker Swarm, and Apache, Mesos, and ECS also will do the same job. So container management tool manages all the deployment, scheduling, scaling, and load balancing as well. It will ensure availability, load balancing, scale up and down based on the user workload. So we talk about this one, right? So previous week also I just mentioned that one more is ECS in AWS, and we did ECS deployment. I mean, okay, that is on the Docker. So ECS is also one of the tool which is managing the containers. So these things, all these tools will do deploying, scheduling, scaling, load balancing, batch execution, rollback, monitoring, and everything it will do. What is Kubernetes? As we already mentioned, it's a software container service, complements Docker. Docker enables you to run multiple containers on a single OS. Kubernetes orchestrates the multiple Docker host nodes. Docker host nodes we can able to manage by Kubernetes. So it automates the both containers provisioning, networking, load distribution, scaling, everything. So to support, AWS already have a Kubernetes kind of service that is your ECS. It's also a container management server managing about your load balancing, security, EBS, volume, IAM roles, and everything. And we talk about the types of clusters we have in ECS. One is backed by Amazon EC2, where you have to manage the deployment. But one is another backed by Fargate, which is a serverless service, so which is being managed by AWS. Then we have one more thing called Elastic Kubernetes Service, which is mainly for those who worked in Kubernetes. They should not feel any discomfort in AWS, so they have created this Elastic Kubernetes service. It will also support major things, whatever it have done in the Kubernetes. It will also confront supports EC migration. So those who are already done in Kubernetes, they can easily move to AWS with the help of EKS. And ECR we just discussed, it's a like a repository kind of thing which you can store your all your images. Whenever you want, you can come and deploy it. Okay, that's what we have seen the previous week. Then we discussed about Kubernetes fundamentals, the birth and the beginning of Kubernetes. So Kubernetes is developed by Google, as I told you. Kubernetes are developed by Google, one of the division called Borg, which is mainly managing thousands of containers internally. So it started in 2014, and Google's open source Kubernetes based on the Borg system it was created. What is the community now? They have been moved. I told you, like CNCF, that is Cloud Native Computing Foundation, now maintains this thriving project. Which one? The Kubernetes is maintained by Cloud Native Computing Foundation. Now, why organizations choose Kubernetes? Mainly auto scaling. So, automatically scale by itself, adjust resources based on demand without manual intervention. We have to do it. So, we have go for this orchestration tool, and it's a self healing tool. Self healing means what? Which is the best example for self healing? Which is the best example for self healing? Yes, Kumar.
Yeah, yeah, yes, sir. Just give me a minute.
Mm-hmm.
Thinking.
Mm.
It restarts failed containers.
Mm?
Automatically restarts.
No, no. Self healing means what? Healing means what?
Recovering.
Ah, which one is a self recovering in your entire life? You saw anything which is self healing by itself? Yes or no?
Yes, sir. I'm
Which is
thinking
that?
the situation.
Mm-hmm. Nothing to think too much and all. You are the self healing person. You get a wound, you are getting cured by itself.
No, no, sir.
No.
I have to apply something, medications.
Even if you don't do also, it will, if you go in sunlight, it will cure.
Yeah, yes,
Correct, na?
correct.
Then which one is self healing? The human only, right? First thing. Then you can able to see what is that. This lizards. Lizards, you see, their tails is cut down. What will happen?
Automatically it will increase.
Uh, so all are self healing, right? So anyone is trying to push or do something for that? No, right?
No,
So same thing here. Self healing means what? We don't want to have a human interruption. See what it will do? It will detect and restart the failed containers to maintain availability. So Docker will manage containers, but even if the container is failed, new container has to be added na. Those things will be managed by Kubernetes. That's why Kubernetes orchestration tool. Next, zero downtime updates. Deploys new version without service interruptions. So we can able to see that. That's why I told you like Kubernetes is a separate course also nowadays.
Yes,
End-to-end
sir, correct.
Kubernetes are there. It will not have allow you to go for interruption. It will keep on going. That means it will keep on updating by itself. Next, load balancing distributes traffic efficiently across all container instances as well. So that is one. We can able to distribute the traffic across all the containers. It's not only one containers. It will transfer the traffic. Real world use cases mainly microservice architectures manage dozens of small independent services that work together. CI/CD pipelines, as I told you, automatic building, testing, deploying applications with tools like Jenkins. Also, it will support. So Kubernetes will support all the DevOps tools as well. Scalable web applications, so handle traffic spikes automatically without manual server provisioning. So we don't want to manually provision the server. Once you install Kubernetes, automatically it will start deploying. Multi-cloud deployment, Kubernetes will support all the cloud public clouds, that is AWS, Azure, GCP, and with consistent management, it can able to manage it also. Then in the Kubernetes architecture, we discussed about the main parts. First one is nodes. First one is nodes. Nodes means what? I told you to. I think I told you to write it, but I'm not sure whether you wrote or not. What is in by node?
It is a server.
Yes, node means wherever you go. Node means server. So now here these nodes are servers that run your containerized applications, and they can be virtual machines or a physical servers also. They can be virtual machines or physical servers also. Kubernetes master. So Kubernetes master here you'll be able to see it will have a API server, scheduler, controller, and etc. So this master is nothing but the brain of the system. It will responsible for mainly managing and controlling the entire Kubernetes cluster. So user interface and CLI. So users can interact with Kubernetes either through a graphical user interface or by using a command line interface tool called kubectl. Next, master and worker nodes. So Kubernetes master nodes manages the cluster, while worker nodes run the actual application containers. So here you can able to see the worker node. This is the master node. So inside the worker node, we have one node. Under one node, you have multiple pods, and these pods are carried by Docker. How can we communicate with these? How can we communicate with these containers and Docker through kubectl? That is kubelet kubectl you'll be able to using for communication. That's the main communication tool for Kubernetes to talk with the containers and Docker. So kubectl master manage node manages the cluster while worker nodes run the application actual application containers as well. So cluster, what is in by a cluster? Cluster is nothing but a collection of nodes. So we saw about node is nothing but collection of parts and Docker. Again, collection of node is called cluster. So that work together to run your application, and it provides a unified view of the available resources as well. So in the control panel, that is in your Kubernetes master, we saw API server, scheduler, control manager, and etc. So what is this API server? So API server is nothing but the central communication hub for all the cluster components. Communication hub means what? It's a main hub. It's a main hub where all the communication will come and go across, like your main bus stop in your city, right? Where all the buses will come. From there, we will be able to travel. Same thing. This API is the main where it will go. The connections will be passed to the master node, worker node, cluster as well. Next one, control manager. It oversees the control process that regulate the cluster states. So it will keep on checking whether any container is repaired, any pod is repaired, anything happen that will keep on checking. Scheduler will assign newly created pods to appropriate worker nodes. So newly created pods will be assigned under the node, and etcd stores all the cluster configuration and state information. ECT will be storing all the cluster configuration and state information. State information means what? State means the default position, the default value which we are giving is a state position. Then again, if you're changing something, that is called update state. State and update state. You're getting,
Yes,
Kumar?
yes, yes,
Okay.
getting.
Now, what is a node? Node is nothing but a server. Either it can be physically or virtually that provide the necessary computing services like CPU, memory, and storage. Cluster nodes can be added or removed from the cluster to scale the available resources up or down. Next, pod. Pod is nothing but a group of one or more containers that are deployed and managed together as a single unit. I think I told you to write this one in your notebook. You wrote
Yes,
it?
yes, yes, I wrote it.
Okay, fine. So now you should be very clear on this. Node is a server. Pod is a group of containers stored in a one single pod. Cluster that can be added or removed from the cluster, scale available resources up or down. So cluster is nothing but group of nodes. Node is nothing but group of pods. Are you getting one, two, three?
Yes.
Worker node anatomy. So worker node, how we can we do it? So kubelet node. This is kubelet is nothing but the node agent that ensure containers are running in pods according to the specification. Then kube proxy which will maintain the network. Proxy means you can understand this is network related. So maintains the network rules for pod communication within and outside the cluster. Pod communication within and outside the cluster also. Container runtime software like Docker that runs the actual containers on each node. So container runtime software like Docker that runs the actual containers on each node. So that's what your container runtime. Now how Kubernetes works? So first one we use the user command. You request a deployment via kubectl or UI. Then the API server. The request is validated and recorded in the etct, which is stored all the configurations. Then scheduler will determine which node should run on the workload. Then the kubelet creates and manages the containers on the node. That's how the Kubernetes will work. So what are the topics we have discussed? First, we discussed about the history. That is, Google built, open sourced in 2014 based on box system. Benefits: automation, scalability, self-healing, zero downtime updates, microservices, CI/CD pipelines, scalable apps, multi-cloud, an architecture control plane plus worker nodes plus pods running containers. So all these things are the things we discussed in this slide. I think we discuss about only about this, or we just talk about the core concepts.
We are yet to start practical from today.
Yes, yes, I know that, but we have to revise all these things, and a few more slides are pending. That also will finish, and then we'll start. Okay.
Okay.
Okay. What are the core concepts? So core concepts, as we already mentioned, core concepts as core Kubernetes concepts. That is parts. Part is nothing but the small deployable units that holds containers. So pods will contain containers. Nodes is a worker machine running your pods. As you mentioned, node inside you have pods. Next, services, that is your network endpoints for accessing pods. Service network endpoint for accessing pods. We have these services. Deployment, manage pod lifecycle and update. So deployment means what? We have to write the procedure of how we are going to deploy all these things. So that's called manage pod lifecycle and updates. Next, replica set, maintain desired number of pods. Replica set means what? Replication. Replica set means what? Replication of the pod. If one pod is getting deleted, another pod should get replaced in that place. That's what replica set. That is replication set. So if we have defined the number of pods as three, means if any pod you deleted, that will get again deployed automatically by itself. That's called as a replica set. I think you wrote this one actually. No, what is a
Oh,
replica set?
I will. I told last time I will refer in PDF. I didn't wrote.
Okay, you didn't wrote anything. Okay,
Yes.
fine. The pod is a building block, basic building block. What is meant by a pod? So we just now said it's the smallest deployment unit in Kubernetes. It can contain one or more containers that can share resources, that can able to share their resources. So main characteristics is pod will share the same IP address, network IP, storage volume, and namespace. Namespace is the title. They are mainly designed to be temporary. What this pods are designed mainly to be temporary. They will keep on replacing the containers. They'll keep on like I think you learned cloud practitioner, right?
Yes, sir. I'm in the middle of the course.
Okay, what will happen when you stop your EC2 instance? Will the host will get changed? And will the address of your EC2 instance will get changed or not?
No, sir. It will get stopped.
When you stop an instance,
It won't change.
it won't change, huh?
Yes.
No, it will change. If you stop the instance, it won't change if you are having a EBS backup. Okay, EBS
Okay.
backup instance, see the IP. This one will get changed. That means what? The server will get changed, but the data will not get changed. The data will be there. If you are stopping the instance, that too for EBS backup. If you are in temporary storage, then the content and everything will get lost, and the server also will get changed. But normally, it's like your monitor, like your if you change your monitor, your data will go.
No.
No, right? So
No. Yes.
same thing. Data will be there, but monitor can able to change. So monitor is your EC2 instance. Okay, when you stop also, they might change the server, but when they change the like monitor, but not the main content will not get changed. Okay, so mainly there for this temporary purpose. Next to node, the worker machine. So what is meant by node? The worker machine in Kubernetes cluster. So it can be a virtual or a physical server that runs the pods. Each node contains the tools needed to run containers, including Kubelet, and container runtime also. Kubelet is nothing but the Kubernetes agent. Kubelet is nothing but the Kubernetes agent which will send you the information to the node whether Dockers or whether containers are in good condition or not. Container runtime. Container runtime means who is carrying the containers? The Docker. So the Docker containers, Docker will have the data of all the containers running on top of it. Next, kube proxy. Kube proxy is mainly for the network. So inside, if you see this containers will both the containers, whatever containers inside the pod, will they communicate each other?
If there are in a single node,
Mm.
uh, I mean in
But
single node, there are two pods. In each pod there is one container. Then there will be a chance.
yes, so it is all inside one pod, na? It is all inside one pod. And if you data you're deleting, it has to be replaced. Or data you want to pass means you have to communicate, correct or not?
Yes, correct.
So you need communication. So mainly this kube proxy will help for networking. Next, what is a stable service network access? So here is the pod OAML file. So pod OAML file, you can see API version, first version, what kind of thing you're going to do. That is called a service. Service just now we learn what is in base service. Network endpoints for accessing pods. This is what the service represents here. So first we are mentioning service metadata. Metadata means what? Data about data. What?
Data about data.
Data about data. So we are inserting an insert data that name is equal to, that means my file name is equal to my service. Next specification we are mentioning. We are mentioning selector. What do I want to select? I want to select an app and the app name is my app. Now we are going to represent the port. Which port we want to run this. Okay, so which port we want to run this? We are mentioning protocol TCP port 80 and target port number 8080. I think previously we done the port number for 5000, correct?
Yes, Python.
Same thing. Port number we are mentioning it as 80 and 8080. Now external traffic, service layer and available ports. So users access your application using a single endpoint. The users access your application using a single endpoint. And service layers routes request to appropriate pods as well. What are the available pods? Receive and process the request. We'll be able to see what are the process it is going to request. Routes request to appropriate pods as well. Services provide stable IP address and DNS names for pods, which are temporary by nature. So as just now we mentioned, it is not node is nothing but a temporary file. We mentioned they are designed for temporary pod. So same thing here. The service provider everything will be for temporary period. Then deployment managing pod lifecycle. So how the deployment management will do. So deployment means what? We first itself we are mentioning that these many pods should run continuously. Like in your office, or let us say you have an office, how many security guys you will put? You will put
Uh, two
two. Why?
for in and out.
In and out. Why two security guys?
One is for bike and another one is for cars. I mean, like that.
What you are saying? So two security guy will work for 24 hours.
Uh, Security guards, I were telling. Okay, I thought only security gate.
No, no, no. Security guard. Hmm.
The security guard means based upon night shifts and everything, based upon the shift wise work.
That's what, man. Your office here is a single office. Let us take some 100 people are working. Let us say a small building. How many security guys you will put? I'm asking.
More than six.
More than six are. Say, okay, 10 people only working in your office. How many security guys you need?
Two.
Why two?
Uh, because he has to sleep.
Hmm.
Uh, another person has to work when one person sleeps.
Hmm. So 12, correct na? So the workload
Yes.
split that equally, no one get hurt or anytime, correct na?
Yes.
Same thing,
Correct.
deployment itself, we are mentioning that I want to run compulsory three pods. Okay, I want to run compulsory three pods means even when we delete also it will get three pods. See here, what we are mentioning here.
Replicas three.
That means what? Minimum three applications, three apps should be keep on running. Okay. Now here we are going to deploy. We are going to write a new file for the pod called deployment file. So here we define how your application should run, such as number of how many pods should run, how many what is the container image to use, and other configuration parameters in the deployment file. And rolling updates. That means what? Roll and update. Seamlessly update your pods without downtime, and new pods are created with the updated version, and old pods are gradually terminated. That means what? Whenever you add new things, you will remove the old one. Correct or not?
Correct.
Without
Correct.
without having a downtime. Without having a downtime, new ports which are created with the updated version are imported, and gradually the old one will get removed. Like how you are shifting from your old house to new house. Will you keep all your things and you will demolish your old house?
No.
Slowly you will move all the things to the new house. Then everything is finished. Then you demolish your old house. Correct? Na? Same thing. It will do by itself. Next, health management. Replace unhealthy pods automatically. As the main job of this container orchestration, that is Kubernetes, is if it's found that any pod is unhealthy, it will not allow it to run. It will automatically delete that and put another pod in that place. So this is a code for that what deployment phase. So metadata there we mentioned service. Here we are mentioning what kind is deployment. Metadata we are mentioning the naming it as my deployment. Replicas 3 manage labels. App is my app. Template metadata same thing. What image we are going to use? We are going to image my image latest. Like previously we have created I think hello demo we created a hello docker.
Yes.
Same thing. Next replica set. As the name says, replica set maintaining pod count. As just now I told you, it is going to maintain the particular pod set. You are giving two securities, na? Same thing. I'm mentioning it as three pods, means three pods compulsory should run, whether you have the things or not, whether you have full pressure or not, or low pressure, nothing. Three pods continuously should run. So that's what the main job is. Here it maintains a specific number of identical pods. Identical pods means what? Same pods, same configuration, everything should be same. So identical pod replicas running at all times, running at all the times. Handles pod failures, so automatically creates new pods when existing ones fail or deleted. So pod failure also handled by itself. It works with deployments, usually managed by deployments rather than configured directly. So it will not only configuring directly, it will also manage deployments. Next, maintains stability. It keeps your application available even during the node failure also. So it is making sure that your application is available even the node failure also, it will keep on running. That's what this replica set mainly needed for. Summary of this Kubernetes concept. Pods are nothing but run containers apart from your application. Apartment for your application. It's like your apartment for your application where it is keep on running. Node is nothing but hosting the pods, physical server or a hotel, let us take. Next, service provides network access, reception desk or mail room. You can compare it with the reception desk or mail room. Next, deployment, managing pod lifecycle, manager giving instructions what you have to do, what you should not do. That's it's like that. You just think about this Kubernetes as a hotel. Your hotel is your node, and your service is your reception desk, and deployment is your managing given instructions, and pod is nothing but your apartment which you are going to run your applications. And replica set maintains a pod count, that is monitoring ensure consistent staffing, that is completely your good in the hotel. It's not like when you call somebody no one is there, all the services are running correctly, and the staffs as they go for night shift or morning shift, only two employees are in that service desk, means two employees should be there always. So 12 hours for two person and the next 12 hours another two-person. So all these are called a replica set. So you can compare it with a real life world hotel. Now how everything connects together starts with deployment first. It will define how many parts you need and what containers you should run. They should run, and replica set handles scaling also. They ensure the right number of pods are always running. They ensure the right number of pods are running, and pods run your containers. So each pod containers your application containers and runs on a node and runs on a node. Then service exposes your pods. They provide stable network endpoints to access your application. Fine. So we'll just see about the commands now. What are the commands we have in your Kubernetes? So welcome to this comprehensive, right? First one, kubectl, kubectl CLI. So kubectl CLI is the first command. So this command, this tool, kubectl command line tool, it is a mainly primary interface for interacting with your kubectl Kubernetes clusters. Then it allows you to deploy applications, inspect resources, and use logs from your command line also. So we can able to log in from your command line and access it. For mainly for Ubuntu environments, you need to add Kubernetes repository to your package resources before installing. So we'll be installing all these things. This ensures you get the official release rather than potentially update outdated versions from default repositories. How will you update your Ubuntu? We learned
No.
no. You opened Ubuntu LTS, right? 24 LTS.
Yes, yes, right.
Follow the first command you write always.
sudo
Sudo
apt
apt.
apt install
No. Update. What?
update.
Apt install update. Correct now. Always whenever you do, you go for update. Same thing only. We have to install this repository first. Okay.
Okay.
So for that, sudo apt update. See here, we already mentioned it here. Sudo apt update. Then sudo apt install y transport clsl and curl and this one and update again and then install kubectl. Now we have to verify the version whether it is installed or not. Okay, this is as okay. Now you understand why we need kubectl. Kubectl is mainly the communication tool tool. Okay, it is allows you to deploy application, inspect resources, and view logs from your command line. So mainly you'll be using this kubectl command. Okay, next
Okay.
Kubernetes cluster. Before deploying your applications, you need a Kubernetes cluster. For deployment and testing purpose, development and testing purpose, we are going to use Minikube, which provides a local, lightweight, local Kubernetes implementation. This is a local tool where you can able to create a repository and wait. The environment setup is done. Okay, so that's what this Minikube will do. So this will help the Kubernetes implementation, and mainly for production environments, managed services and all, we go for EKS, EJA, and AKS offer more robust solution with built-in redundancy. But for testing and development, you can use this Minikube. Next, Minikube runs a single node Kubernetes cluster inside a VM on your local machine only, making it perfect for learning and development work without incurring cloud clusters. So as it's an open source, we will not going to take any much amount or anything. So it will be helpful for us to create our application and set the development, testing, production environments. I mean testing and development environment. So how to do that? So you can able to see cube Adam, cube admin, initiate pod network. This is the 5P address which we are giving, but for logging you have to type this one, the cube admin. Production environments we use just now we mentioned EKS, EGK, AKS. What is EKS? Amazon EKS, Elastic Kubernetes Service. GKE is Google with cloud, Elastic Google Kubernetes cluster. Next EKS, AKS, Azure Kubernetes cluster source. So these provide scalable and manageable upgrades. Ideal finally for learning, testing, and deployment, we need this kube admin. Next, creating Kubernetes namespace. Namespace provides a mechanism for isolating group of resources. Namespace is nothing but I told you it's like you're creating a WhatsApp group. Why you will create a WhatsApp group? Whom will you add it?
Relatives.
Relatives, huh? You're going for a trip. What you will do? How will you communicate with 10 people?
Yeah, we'll add those in one. We'll create group and we'll add those people in group.
That means what?
Within a single group, we can communicate with multiple people.
Hmm. Yes. So within single thing, fine. So same thing here. We are going to create a namespace. Namespace is nothing but we are going to isolate our resources what we have created. Like we created my app na in the codes.
Yes.
Previous slides I showed you my app na.
Yes. Yes.
My app is a namespace. That is you are creating your own application name so that all the resources whatever you are adding under that it will come into that flow. So creating a single cluster, we are creating this namespace. They are essential for multi-tenant environment where multiple teams or projects share the same Kubernetes cluster. They help organize resources and prevent naming conflicts mainly between different applications or environments also. So think of namespace as a virtual cluster within a physical cluster. Common practice including create separate namespace for different environments. For example, I'm going to create only for development means development one namespace, staging one namespace, production one namespace, are they like different application components. So creating namespace is easy, like how we created the previous one. I think we created one node file and all, na? The BMI calculator, how we created.
Yes. Yes.
Same thing, we are going to create kubectl create namespace div. That's it. So this command is mainly to establish a new namespace. Next, to confirm the namespace exists in your cluster, we just check kubectl get namespaces. What are all the cluster names is there, it will display. Use this namespace, include the namespace in subsequent commands in n flag or in OAML definitions. That's what we do. We did it with hyphen n flag. So this is one of the command. Maybe when you do the program, you will come to know. Now, creating Kubernetes pods. How to create Kubernetes pods? So pods are the smallest deployment units in Kubernetes. We already mentioned. Each pod represents a single instance of a running process. Each instance represents a single instance of a running process in your cluster and can contain one or more containers also that share storage and network resources. So containers within the same pod can communicate with each other tools using local host as well. While you can create pods directly, it's generally better to use higher level abstractions like deployments which manage pods for you. However, understanding how to create individual pods is fundamental to Kubernetes knowledge. So creating a fundamental is nothing simple. First you see this, first we create a YAML file. In that we are mentioning API version 1, kind is pod, metadata. The pod name we are giving it as hello pod. And dev, the namespace we are giving it as dev, that is for development process place. Like the just now in the WhatsApp group, the group name this is. Now related items we put here. Specs containers name is hello container. We are giving it as the container name. What image I want to, what server I want to launch is Nginx image, and which port I want to display. It's 80 port number 80. So how to apply this pod? You can just mention kubectl apply hyphen f pod dot yaml. Next, verify pod is created or not. So we just as usual put kubectl get pods hyphen n div and describe the pod. You can able to mention kubectl describe pod hello hyphen pod hyphen n. So these are the basic commands. Kubectl apply get pods and describe. Next, kubectl deployments. How to deploy kubectl. So another file deployments provide declarative updates for pods and replica sets. So they allow you to describe an application's life cycle, including which image to use and the number of pods to run, how to update them. Deployments are ideally for stateless applications. Just now in the previous slide we discussed, right? What are these things? Okay, there is one more file called deployment file. So it will give you all the information of how to run, how to update the pods. So it can able to, it is mainly for ideally state for stateless applications where any instances can handle any request. Instances means what? Instance means
Yeah,
server.
server.
Server in the EC2 instance. That's what instances can handle any request. Server can handle any request. The key advantage of deployment over direct pod creation is the ability to maintain a specific number of replica sets. Replicas means what I told you. So it's the main thing. Main thing is how many number of instances should run, nodes should run, how many number of pods should run automatically, replacing any that fail and becoming unresponsive. So they also facilitate rolling updates and rollbacks for applications versions. So deployment is mainly for managing multiple replicas and updates. It will ensure desired number of pods are running and run the application containers. So how to apply this command? You can able to see kubectl apply hyphen f deployment dot yaml. Check the deployment status. So get to the deployment status. Just kubectl get deployments hyphen n dev and kubectl gets pod hyphen n div. So these are the checking commands, and these are the apply commands. So same thing we saw in here also. Kubectl apply pod dot yaml. Here we want to mention deployment dot yaml. So kubectl apply hyphen f is nothing but hyphen file. So hyphen f file deploy, and hyphen n is nothing but namespace. Just now we mentioned a hyphen n namespace div. Next, creating kubectl services. To services offers types of different expose needs: cluster IP address, cluster IP services, which are only accessible within the cluster, while node port and load balancer types provides external access through different mechanisms. So define service YAML will create a service specification file. Apply services will use kubectl to create the service. So we can able to use this kubectl mainly to create the services, verify whether the services existed already, and connect to the service. So access your application via that particular service. First to create the service, use create the service, verify that service is there, and access to your application. So here you see service YML file service nginx service. We are going to take the service called nginx service in the namespace called development, and the app itself nginx and port number 80. What type of port? It's a node port. So while node port and load balancer types provide external access through different mechanism. External access means what? Public and able to access. That's what I think. Previous week we have done load balancer, na? Do you remember?
Yes,
Load balancer is mainly for what?
to divert traffic.
Mm. Not divert traffic, to balance the traffic.
Yes.
Okay. Okay. Next, kubectl commands. What are the things we learned up to now? So essential kubectl commands. So mastering kubectl commands is essential for effective Kubernetes management. These commands form the foundation for your daily interaction with clusters, allowing you to deploy, inspect, and troubleshoot applications efficiently. Remember that most commands can be executed within the hyphen n flag to specify a namespace, and many support the all namespaces option to view resources across the entire cluster. See the O flag, the object flag allows you to control output from output. This is hyphen OS output flag allows you to control output format with options like YML, JSON, while providing your different levels of detail. So to get the output, you put hyphen O. Okay, now you see the command line. So install CLI, you put sudo install hyphen y is kubectl, initialization kube admin initiate, namespace kube create namespace dev, application pod applying pod and deployment. You can able to see kubectl apply hyphen p pod hyphen f pod yml, and get pods to get the how many mods are running. Next, expose service, you can put hyphen f service yml, and delete deployment, you can say delete hyphen f deployment, and logs, you can put logs pod name hyphen n dev. You can take a screenshot later, maybe you can write it in your notebook also.
Okay,
Okay.
sure. I'll take screenshot.
Yes. You're watching from your system only, right?
Yes, laptop.
Okay.
Done.
Done. Okay. So let me go to the next one. Kubectl commands for the beginners guides to Kubernetes. First command is kubectl. Kubectl is mainly is the primary interface for interacting with the Kubernetes cluster. As I told, it lets you control Kubernetes from your terminal itself. The core functionality is mainly, you see, the Kubernetes will control. You can deploy applications, inspect resources, view logs, and manage every aspect of your cluster's operations as well. So using kubectl, you can able to interact with Kubernetes and you can manage everything from the cluster's point of view. You can deploy applications, inspect resources, and view logs, manage the clusters as well. That is one. So essential kubectl commands, learn the basics. We'll cover six fundamental commands every Kubernetes user should know. Each command includes real-world usage examples and discover the right situations for each command. We'll see the real-life commands. So kubectl get pods. Kubectl get pods. What get pods? As the name itself says, get pods. That is, get the list of pods. So what it does, it displays a list of all the running pods in the current namespace. And kubectl get pods. And kubectl get pods is the main command. So it will check the health and status of your pods mainly. Where will be using this get pods to check whether how many pods are running, what is its status. So use this daily to monitor your applications as well. We'll be using this next to kubectl create. How what it does? Kubectl create will do. It will create the Kubernetes resource from files or direct commands. Command is kubectl create -f app.yml. That is, app is a file name. So used mainly for manual resource creation. When starting a new applications, we'll use this command called kubectl create. This is the second command. Next, kubectl logs. As the name itself says, show the log output from the containers inside the pod. What are all the containers is doing? What is the show the log output from containers inside the pods. So kubectl logs my pod. Kubectl logs my pod. That is the command here. So externally, mainly when will you using? It's mainly for debugging and checking. When you will go and check the logs, mainly for debugging and checking only. Checking your application's output, we use this logs. Next, kubectl apply, mainly for creating a file. You can able to write your desired configuration in YML file. Then mention apply -f for the file deployment.yml is a file name. So that's your fourth command. Kubectl apply -f deployment.yml, mainly for resources whichever we have created. If missing or updating, if they exist, we'll check it. Next, kubectl delete. As the name itself says, it's going to delete. So first to identify the resources that you want to remove and type kubectl delete pod my pod. So my pod is a file which you are going to delete. So delete the pod name my pod. Okay, file my pod is a file name. What I want to delete? I want to delete the pod. Next, verify removal. Confirm the resources has been deleted. Confirm the resources has been deleted. We can able to verify it also. That's the fifth command. Sixth command, config file. So cluster config, mainly the control cluster connection settings and contexts. You can able to view the settings of the configuration of the Kubernetes. Just mention kubectl config view, configuration view. That's what config view is the command. So mainly you want to move between different clusters and namespaces. We can able to use this configuration up to what settings it has been done, which under which namespace this kubectl is coming. For that we need this kubectl configuration view. Okay. So what are the commands we learn now? So kubectl get pods mainly for list all the running pods. Kubectl create -f create the resources from files. Kube logs source container logs. Kubectl apply applies configurations. Kubectl delete removes resources. Kubectl configuration manage clusters connections. So all these things we have done. Fine. We have done everything. Now we'll go. You have written this one. You take a screenshot of this one also.
Okay, sure, I'm taking.
Done.
No, 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 not yet. Please give me a moment.
Okay.
Yeah, done.
Okay.
Done.
Okay. One more slide. I'll just show you. You just take a screenshot of that also. That will be
Okay.
helpful. So important question in any interviews is mainly containers, pod, and deployment. Okay. So
Okay.
what is meant by a container? What is meant by a pod? What is meant by a deployment? So container, as we know that it's a standalone executable package that includes everything need to run in a piece of software. So we know what is meant by containers as we learned in Docker. It will be having code, runtime, libraries, everything. The example mainly is the Docker containers. We call it as container D. And role in the Kubernetes is it's a basic unit for applications code inside a pod because pod will contain containers. So it runs your actual applications. Mainly the containers only run your actual application. Example Node, JS or Nginx. Next pod, that is the smallest deployable unit in the Kubernetes. One of the main one or more containers that share the same IP address, same network, storage, and namespace. Why pods? Containers in the same pod can communicate via localhost and are scheduled together. So Kubernetes does not run containers directly; it runs pods which hold containers. Next, deployment, a high-level Kubernetes object that manages pods. It automates creation of pods, scaling up and down, rolling updates and rollbacks. And the key point is you define the desired state, example 3 replicas of a pod, and the deployment ensures it. So what are the three concepts? Contains, managed by, and key use. So container is nothing but app plus dependency files will be there, which is inside a pod and runs the actual application. Pod is nothing but one or more containers. That is a deployment as replica set, and key use is mainly smallest deployable unit in the Kubernetes. Deployment, it's a replica set and pods. It's a Kubernetes controlled by Kubernetes controller and manages pods lifecycle and scaling. You've done this. You took the
Yes, I have
screenshot.
taken screenshot. Yes.
Okay, fine. Fine. So you can just share your entire screen. We'll go for pods and this one,
Sure. I
Kubernetes.
am sharing my screen.
Hmm.
Are you able to see my screen?
Mhm. 1 month. Ah, yes. Okay, go to your browser and type kubectl. Yes, install kubectl install. You can say. Come down. Install tools is there. Na? Click install tools. Come down slowly. Come down. Install for Windows is there. Na? Come down. Come down. Come down. Come down. Wait. Wait. There's a link. Na? Kubectl curl.clo. No, the first one. You have installed. Use this command. First one. Copy that. Fully you copy.
Done.
Okay, go to your command prompt. Open your command prompt. Okay, paste that. Enter.
Kubernetes not yet installed in my laptop. First time this is.
Mm-hmm. Okay, go there to the browser page. You are able to see first one direct download. Click that release page. First one kubectl Darwin operating system. Copy the link and paste it, or click that file. I think you have installed as the command prompt you open as an administrator.
No, no, not as administrator. Shall I open as administrator?
Open as an administrator and paste. Let us see. No, not this one. That curl link. You have to paste.
Okay, okay.
Back. Click back.
One second. Same output.
Okay, 1 minute. Okay, I posted a command in the chat box. Copy this link and paste.
Okay.
This is your permission is not granted.
Total single link, right?
Oh,
Total
single
command.
link. Single link. Hmm. Okay. Again, type dir kubectl directory.
Dir kubectl.
Directory.
The command correct is this command dir space kubectl.
Put I mentioned. Na?
Oh, okay, okay. You have mentioned. Okay, one second.
Copy and paste.
Got it.
Okay, directory is there. Now move this. I'm just pasting the other command again. Copy and paste that command.
Okay.
Mode. Wait. Okay. Now verify kubectl. Kubectl space version. No. Cube means now henceforth you mean fix your mind. Cube KUBE.
Okay, okay.
Kubectl space version space hyphen client. Okay. Now kubectl version came. Okay. Now client version v135. Okay. Now we'll type one more kubectl version client output.yml. What file it is showing? I've pasted the command there in the Zoom. Just paste it
Okay.
in the Zoom. Yes, you're able to see the output file version, build a data, compile, git commit, trade major version, platform, everything. All the versions of your kubectl is showing. Now we will type the cluster version. Type kubectl space cluster.
-info.
Yes. You're able to see it is installed, but disagree problems are there. Correct. Fine.
Yes.
So we are going to install that mini cube, which I said, the mini cube which we are going to install. It's a lightweight local repository we are going to create. For that type winget. I'm pasting the code in the command. Winget install kubernetes dot minikube.
Okay.
Yes, minikube is installing. Agree all the resource. Yes, you give it. Okay, so package version installed, package everything successfully. In our command in our system, it is everything is done. Now we'll go for our Linux file. So go open your Ubuntu
Okay.
24 LTS.
As administrator.
Yes, administrator, that's fine. Mm, okay. Normally, if you open Ubuntu, what is showing? Is it your page is showing? Without
Same.
administrator.
It won't ask yes or no.
Okay, fine, leave it. Now, go open your Docker actually. Docker is opened.
Yes, it is
Docker
already
is
open.
okay. Click images. Okay. Fine. So in the Ubuntu now, all the commands are in the Ubuntu only. First, we will install the Ubuntu, the same kubectl. Go to Ubuntu. I pasted one more command for Ubuntu. Just copy and paste the same thing like command prompt we have done. Na?
Yes.
Same thing we are going to do it for this one, Ubuntu.
Command not found.
What is that last tilde symbol is not there actually.
Okay. Okay. Got it. I think control V is not working here.
Uh, you delete that first lines and all. Before curl something is there. Na? And the last line also the tilde symbol is there. That also you have to remove.
Yeah. Sure. Sure. Got it. Curl IO.
Mm.
Up to this 200.
Yes. Move your LTS left side. That screen left side. On left side. Slow, slow, slow. Inside, inside. Right side. Slowly right side. Left side. Slight left side now. Okay, fine. Okay, fix it, fix it. Okay, let it get complete.
ശരിക്കും നോക്ക്.
Mm, Staying too much time.
Yes.
Let it download 1 minute. I'll be back.
Okay, sure.
Still it is loading. What is this? Okay, open your Docker desktop.
Okay.
Mm. Go back side. Mm. Left side click Kubernetes. Create cluster. Yes, create. Leave it. Create. Install.
Done.
Okay, fine. So Kubernetes cluster is activated. You see pods, nothing is showing. Correct, na?
Yes.
No pods are there. Okay, right side below you see no pods are there. Okay, leave it. Minimize and keep this. Minimize this and keep it. Now come to your LTS.
Completed.
Now this is admin. LTS you go.
It is still pending.
Okay, that is MB size. That should be, it will be taking some time. Um, that is 133 M. Now we are in 54 only. Your network is slow, I think so.
Oh, Wi-Fi router is beside me only.
Okay. Okay. Let us wait. Okay.
Done. It is completed.
You pressed anything or it is done by itself?
It is done by itself.
Oh. Now we have done just to type cluster info. Kubectl cluster info and check. No. Kubectl cluster info and check whether any cluster is there. Oh, no, cluster hyphen info. Cluster hyphen info.
Okay. Okay.
I have given you the no, already. Just press arrow, it will come. Okay, control plane is running at Kubernetes. Code is running. Oh, no cluster. Now we have to install that mini cube. Okay.
Okay.
For that, we need to put the command. I have just pasted the command in the chat box for cube, mini cube. Just to copy and paste that.
Curl hyphen IO, elbow. That one.
Mm.
Paste is now. Is there any command for paste?
Right click, control right click. Cube.
Control right click. It not working.
Then copy, paste V, control shift V. Copy, Control Shift V. It's not pasting. Control V
Yes.
is pasting.
Not control V also not.
Okay, do one thing. Go there on the top on the LTS right click, LTS page right click on the top of this window. Right click. Right click. Settings, properties. Go there, properties. Use Control Shift V. Check that box. That one. Fourth one. Now paste it. Okay. Now you go copy and paste it. Control Shift V.
Okay, okay.
Yes. Enter. Okay. Minikube is getting installed. Done. 133 MB done. Next command. I have pasted it. Mini install. Sudo install Minikube Linux.
Okay.
Install that one and I'll give you password.
Done.
Yes. Now type Minikube space version. Minikube. Yes. You have installed this one. Now Minikube start. Minikube space start. Yes, it is pulling all the downloading Kubernetes files and everything. It will download. Done. It's creating.
No, it's still it is in progress.
Mm-mm.
I have to buy hard all these commands, right?
No, first time only the Minikube everything you will install. Later, then you'll be using only the kubectl3 commands only. Apply,
Okay.
run. That's it.
Is there in
Get
interview perspective any important comments are there in this?
No,
Okay.
I told you the screenshots, na.
Yes, yes, yes.
Those are the interview comments.
Okay, got it. Oh, it is completed.
These are only one-time things. Okay.
Okay.
Next command I have pasted. You just copy and paste that.
Okay, okay. Done.
Mhm. Okay. So Docker drive is started. Next, we are going to configure this using Docker desktop. So another command I pasted: kubectl configure use context Docker desktop. That's what the configuration which we have learnt, the command which we learnt there in the theory. Yes, switching to context is Docker desktop. Now we have set everything. Now first we'll check what are the nodes already present in the Kubernetes. So type kubectl space get nodes. Get nodes. No get no get the space nodes. Yes, this is the main command. You see Docker desktop is ready. Okay.
Okay.
Now Docker desktop, that is your Ubuntu system is configured with the kubectl, and who this Kubernetes is going to maintain which containers? The Docker containers. Okay.
Okay.
Now we go to create a pod. So how to create a pod? By default pod will take. So go to your browser, that kubectl Kubernetes pods we have mentioned. Na? There you come left side, you see, come down. Okay, go and type in your new browser Kubernetes pods. That's it. See that pods is there na, below. That one. Come down. Come down. Mm, come down. The first one. Copy this command. Copy. Yes. Copy this code. Nano. You type nano. We'll create a nano file. Nano space pod.yml. Pod.yml. Oh, sorry. YML you type. YML you type.
YML. Okay.
YML you type. Enter. Yes, Control Shift V or right click and paste it. Anything is working, it's fine. Yes, nothing you have to do. How to save this nano files? Do you
Y-
remember?
Yes, yes. The Linux command is there.
Control O, Control O, Enter. See below Enter. Yes, Control X. That's it. So part file is created. Now we'll run this file. So Kubernetes has to run. So go see the command kubectl create. We learned the create command.
Yes, yes.
Create command you have to type.
Done.
Yes, so pod nginx file is created. We put the server called nginx. Now we'll check whether it is working fine or not in the Docker desktop. So type kubectl get pods. Kubectl get pods. I have mentioned the command there in the Zoom. Kubectl get pods space hyphen o wide. Just to take the output. Yes, you make a note of the IP address. IP address is there now 101.0.6. Put it in the notepad and keep it. Yes. Now again type minikube space start. Now we created the pod file which is inside the Docker. It has to pull it. Yes,
Done.
done. Now you type minikube space SSH. Minikube SSH. What is this minikube you're getting? This is like your server. This is like your server EC2 instance. Okay, SSH we used to have in EC2, right?
Yes. Yes.
Same thing,
Yes.
minikube SSH. Now we see Docker at the rate minikube we have logged in. Now you type curl curl definition I told you. C for client. Okay, client URL. Okay, URL here is what? Space curl space the IP address 10.1.0.6. That's it. Enter. You see the file has been created HTML file. Welcome to Nginx. Correct, na?
Yes.
That
Correct.
welcome to Nginx we have been displayed. Now you go and check your Kubernetes. I mean Docker desktop. Go to your desktop, Docker desktop. Now you see Nginx pods is running right side below. You see?
Yes. Yes.
Yes. So our pod is running successfully. We have created the pod. We are running the pod in the Kubernetes. Now you see that engine is then a below in this Docker engine. Below. You see right side, three dots is there. No?
Yes. Yes.
That one you click, you see Docker desktop is running and Kubernetes is context. You see Kubernetes context. It has been created as Docker desktop. Fine. So Kubernetes is running now. Now we created the pod. We will now delete this pod. Okay.
Okay.
We will delete this pod and check how it is seeing. So go out, go to the command prompts. So we are in which login now? Previously it was Manas desktop, correct na?
Yes. Correct.
Now where you are
Docker at
here
the
it's a
minikube.
mini cube. So to come out of this, what you have to type? We have to exit out of this. So what you have to type? To exit from somewhere, what you have to type? Exit. Type
CD.
exit. Type exit.
Okay.
Hmm. That's it. Yes, you logged out. Now we are going to delete the pod. So deleting the pod command, you took the screenshot now.
Yes.
What is that? Kubectl delete pod space delete space pod space nginx. Enter.
I think spelling mistakes. NGINX.
Hmm.
NGINX. Correct only.
What you have typed? Nginx pod. What is the pod we created? We created nginx only, right?
Yes. Correct only. I entered. Here in Docker desktop also same. NGINX.
Run that pod. Kubectl again. Type kubectl.
Okay. Okay. I will copy paste this one.
You give any space or something? Check.
No. No space.
Mm-hmm. It's running correctly, right? Kubectl delete pod nginx. Okay, first we'll check the pod names, then we'll delete it. First go and check kubectl get pods.
Okay.
Mhm.
Get pods is a single name, right?
Hmm. Get get space pods. You already returned this.
Okay, got it.
Yes, in case.
It is showing no resources found in default namespace.
What has that? Okay, namespace is not mentioned. That's why you copy pasted the code only, right? Exactly what namespace we have given.
Yes, yes. Kubectl get pods hyphen and hyphen dev. That's one, right?
I pasted on command. Just go and check.
Okay.
Name only, container name only I have given. Namespace we didn't give. Meta name we have given as Nginx. That also not coming.
Yes.
Go there to the browser. What code we copied, we go there. Wait. This is what I mentioned, right? We didn't put the name. Okay, type this command kubectl get pods hyphen hyphen
Okay.
all namespace. It is running in the existing namespace. Okay, cube system. Nginx where it is present. Nginx is not present. 1 minute. Okay, we applied nginx first. Type kubectl apply f hyphen f nginx.yml. We put pod.yml file, right? Okay,
Okay.
that's not going inside.
Does not exist.
Now first create a kubectl. That pod yml later type nano space nginx.yml.
YML or YAML?
Okay, yml also fine. Anything is fine. Copy that code of Kubernetes.
This one, right?
Copy, paste it.
Control O,
Mm,
Control X.
yes, Control O, Control Enter, Control X, Control O, Enter, Control X. Now you type delete command. That is
Okay.
first you get kubectl get pods. Let us first get pods. Kubectl get space pods.
No resources found.
Namespace we are not giving. We are copying the same code only. Okay. Instead of this, we will create an email deployment file. Okay.
Okay.
Go to Kubernetes deployment page. First itself will be there. Go for the pods. You get the pods now. Same thing. Go and type it in Google itself. Kubernetes deployment. Come down. Deployment engine. Let's copy that. Now go and type it in your this one. Come on. Yes. Nano space deployment.yml. Mm, paste it. Okay. Wait. Here is the namespace. Everything is there. Container. Uh, mm.
Okay, shall I save?
Yes. Save it. Save it. Control O. Now apply that's kubectl. Apply kubectl space apply hyphen f space hyphen f space deployment.yml. Oh, wait. First create. Instead of apply, first create. Create hyphen y hyphen f
Hyphen O.
hyphen f space deployment.yml. YML.
Created.
Deployment nginx hyphen deployment created. Now you put kubectl apply hyphen f deployment.yml.
It thrown error.
Missing annotation will be passed automatically. Do one thing, just create will deleted it, right? Okay, you're done. Just apply, right? You created and then apply.
Yes.
Okay, that is it saying that it's just a warning only. You just to type kubectl space get space deployments.
Deployment. Okay.
Deployments, yes, yes, yes. Yes, you see, Nginx deployment is done.
Yes.
Okay. Now you type get ports, kubectl get ports.
Uh,
Hmm,
kubectl get ports.
hmm. Yes, you are able to see three things are running.
Yes.
Yes, why three things are running? Why three servers are running? Because you see the command backside kubectl, Kubernetes, go back. You're able to see the replica set is what?
3.
Three. So three replications should be there permanently.
Okay.
Okay. So now you can just type kubectl get space rs. Enter. Yes, one file is running. Okay, it's one file. Major file is what? Major instance. The name of the file is 4486
4486.
866C. Correct, na?
Yes.
Apart
Yes.
from that, you're having these IDs. So this is displaying just all the pods running in that and the replica set. And now we'll see. We'll delete one, and then we'll see how it is replicating again. Okay. So
Okay.
first to get that, you type kubectl get pods space hyphen w. That is watching, mainly watching. That's what w. Oh no one. Yes. You're able to see one out of one running. Now you will take only one first one. You see a first command, ngx deployment. Copy the first one. Nginx deployment hyphen this one. That one. Copy. Now to delete this one, what happened? You didn't have this one. Control C. You just give it, and we'll delete one thing. Kubectl space delete pods space pods space. You just paste that. So only one. So wait, what you are deleting? 4K
WG9.
WG9. So WG9 should get deleted, and the other should get added by itself. Okay, the third one should get added by itself. Why? Because we have mentioned replica.
Okay.
Okay, now enter. Okay, it's deleted.
Deleted.
Yes. So to see that, what we have to do?
We have to again kubectl get pods -w.
Same thing. Do it.
But it not deleted.
Why not deleted? It's
No,
deleted.
yeah, yes, deleted. Sorry, deleted. Yes,
It's deleted. It created another replication.
yes, correct, correct.
Okay, so like this we can able to give the commands and the replica sets. So major file is this one, this deployment command. Okay, where you are going to type this. Previously I think pod. Now you go to this kubectl desktop and let us see that Kubernetes. Anything is added. This deployment is added.
Where?
Docker desktop. Docker
Okay,
desktop.
okay, okay.
Click images. Okay, and Kubernetes. Okay, Nginx only running in the pods. So this Nginx machine only we are running it. So this command you see kubectl create deployment my app and hyphen image, and in the set go to Nginx, because Nginx is created. Nginx pods is already created. With the same image we can able to create multiple deployments. For that it is saying this command. Okay.
Okay.
So we have done the first level of lab. We know how to replicate things. I think you are making a note of all these commands as well, right?
Yes, right in Notepad.
Notepad. Fine. Now you can just check the logs. So type kubectl logs, kubectl space logs space nginx. Okay, nginx is the pod name which we have not given, right?
Yes.
Deployments you just to give.
Deployments.
Let us check. No, kubectl logs nginx hyphen deployment. Deployment and hyphen, that's the name of the file, the namespace which we are giving.
After Nginx, no space. Huh?
After nginx no space, because there you see the file name is nginx hyphen
Yes.
deployment, that's the namespace. Okay, give
Deployment or deployments.
deployment. Okay, previously you mentioned pod, right?
Yes.
Okay, go types kubectl space describe pod nginx.
Describe.
Describe pod nginx. Okay, go scroll above. Yes. So you can able to see images nginx, container is docker, image ID, port number. Another thing is showing. Fine. So this is also one of the command to check the description of the pod. Okay. I think we have written it in the screenshot. Describe command. Okay, type kubectl get deployments, kubectl get pods, all together. Kubectl get deployments.
Yeah. kubectl space get space pods
No, no, no. First deployments you give deployments space kubectl get pods.
in single line.
Same line. We give. Let us try that. And yes,
Not found.
not found. Right. Okay. One by one only we'll be able to give it. Fine. What is the name of the file which we have given? Go there to Kubernetes page, browser page. In the deployment namespace, what we have given? Nginx deployment. Okay. Nginx deployment, right?
Yes.
My container. What is the container name we have given? Nginx. Okay, we'll try to change the read replicas. So my deployment is not my deployment, it is Nginx deployment. Okay, change this. I have put a command you see.
Okay. Okay.
Kubectl scale deployment nginx hyphen deployment is equal to replicas is equal to 5.
Scaled.
Okay, now previously we gave the replicas as what? How many replicas?
3.
Okay, now we have reclaim scale it as 5. So go and check. How will you check? Type kubectl get deployments.
Yeah. 5.
Okay, fine. Now how will you view it fully? All the files running.
In Docker desktop.
Oh, here. Kubectl get pods. Okay, you're able to see that 5 pods are running inside this kubectl.
Yes.
Okay, fine. Write this command also and keep it in your notepad.
Sure. One second.
Okay, done now.
Done.
Okay, fine. So we'll see the remaining. That is the next phase of practical tomorrow. Okay,
Okay. Sure.
great.
Okay.
Fine.
Shall I stop this?
Yes. You can stop sharing.
No,
Fine.
no. This is
I think.
Docker desktop.
Yes, you can Docker desktop. You can stop it. Everything you can. I think only it's running, right?
Yes.
You know how to delete it. What is the delete command? But it will not do anything. It's not going to charge anything. Nothing.
Okay. I will leave it like this only for tomorrow.
Yes. For tomorrow. Yes. Okay. When you stop the system itself, it will stop. Everything will stop.
Okay.
Okay. Kumar, we'll see you tomorrow. Maybe at
Okay.
3 o'clock. Okay. I'll
O-
post it.
Okay. Sure.
Yeah.
Bye.
Bye.